x is
3e 3x.
Very good. And the derivative of e to the x is e to the x. Okay, we have to set this equal to 0. We know it's always defined. E to the x, e to 3x, they're never undefined. So I have f prime of x equals 0. Okay, so let's solve this equation. It's not a friendly equation, but we will figure it out. So I think I'm on page 9. Okay, so let's take a look. Look how much, and we haven't even started the table, basically. Okay, so it's a lot of work. Okay, so 3e to 3x minus e to x equals 0. Okay. How do I think about this? No, I will not move e to the x to the other side just yet. I can divide. I can divide by e to the x. How come? E to the x is never 0. I can never divide by x. If you remember, I think we wrote that note a long time ago. But I can divide by e to the x because e to the x is never 0. Or you can say, let's not divide, we can factor. That's possible too. Now remember how we get this. One option is e to the x, everything to the third. Another option will be e to x plus 2x, which is e to the x times e to 2x. I'd rather stick with this. Same thing. Why? Because 3 times x is 3x. Copy the base, multiply the exponents, and get 3x. So 3, e to the x, everything to the third, minus e to the x equals 0. Factor out e to the x, so we get 3 e to 2x minus 1 equals 0. 3x minus 1x is 2x. So we have one option, e to the x to be 0, never. E to the x is never 0. And the other option is e to 2x 1/3. I moved 1 to the other side and divided by 3. How do I solve this? Because I need x. Ugly situation, right? So I have to apply natural log to both sides. So I have 2x equals natural log 1/3, or x. That's why we did all this in chapter 2. Natural log of 1/3 divided by 2. Who knows what this is? I have to approximate it. I have no idea what it is. So I'll share my screen and plug it in. So I have natural log. Where is my natural log? Of 1 divided by 3. Close and divide by 2. Don't forget to close the parenthesis. And what do I get? A tiny number, negative 0.55. Okay. So negative 0.55. This is the only critical number. Okay. 0 is in the table, negative 0.55, and 0 for the derivative. Now I have to study the sign of the derivative left and right, and I have to plug this in the function. So in this, I have to plug this in to find the y value. Okay? This is not a friendly function at all. Okay. I keep saying that. And I chose it. So I can't complain. If I chose it, I have to stick with it now. So it was e to 3x minus e to x. Okay, I omitted my special parentheses. That's okay. Okay, so now second and negative 0.55. Beautiful numbers too. Gorgeous numbers. Okay, negative 0.34. And graph these. Wonderful. Okay, so now I need to find the sign of the derivative. Okay, here's my derivative. And I'm going to punch it in the graphing calculator. I'm going to share my screen. As the second function, y2, I have 3 e to 3x and minus e to the x. X. Okay, so you can de-highlight this one if you'd like and work with the derivative only. Okay, of course, wait a second. So I want to plug in, it's not an error for this function, it's always defined, but the calculator cannot compute. If you want to plug in 1,000, it's not going to be able to. It's not that powerful. Okay, so I want to plug in a negative 10. Negative 10 will be fine. It will give me the sign with negative 10. So it's a negative number. It's sufficient to plug in 0 to see the sign on the other side. It's positive. Okay, good. So now I know I almost have to stop. I know. Yes, I have half a minute. Okay, so from 0 to, I have to check. I have to make sure that these two rows work well together. Otherwise, I have a mistake. From 0 to negative 0.34, what does the function do?
It decreases.
Good. Is that supported by the sign of the first derivative?
Yes.
Good. From negative 3.4, negative 0.34 to positive infinity, what does the function do?
Increase.
Yes. Is that supported by the sign of the first derivative?
Yes.
Perfect. What type of point is this? Negative 0.55, negative 0.34.
Relative min.
Awesome. I know I have to stop. I'll stop. So the function, the table gave us the function is decreasing between negative infinity to negative 0.55. It's increasing between negative 0.55 and infinity. It has a relative minimum at this point, and we did not get the chance to determine the second derivative and see if it has an inflection point and a sign. So we're going to continue right from this point on Wednesday.